In last class, we have seen hypothesis testing based on statistical significance. Today, we will see errors which are possible in hypothesis testing. Statistically significant result cannot prove the research hypothesis 100% correct. Means if you reject null hypothesis, alternate hypothesis is true, but this result is not always correct. Because we already seen hypothesis always refers about the population parameter mu, but while testing the validity of this null hypothesis, we consider sample statistic. Based on that sample statistic, we will reject or do not reject null hypothesis. Means based on this z value, we try to reject this null hypothesis or will not reject this null hypothesis. This z value is based on sample. So here if observed value, see here, if observed p-value less than alpha, then you will reject null hypothesis. Even if we test based on critical regions, here also this minus 1.96 and 1.96 are the z scores for this probability value 0.025, and here it is the cumulative probability 0.975. So decision is based on probabilities. There is always chance of making incorrect conclusion regarding rejecting null hypothesis or not rejecting null hypothesis. While making decision in hypothesis testing, there are two possible errors. One is type 1 error and another one is type 2 error. Type 1 error is the conditional probability of false rejection of null hypothesis when it is true. We can write like this: type 1 error, probability of rejecting null hypothesis. Actually, when this null hypothesis is true, it is the conditional probability. It is impossible to avoid errors in hypothesis testing. So it is important to consider the amount of risk one is willing to take falsely reject this null hypothesis. That is the type 1 error. The amount of falsely rejecting the null hypothesis is called the significance level, denoted with the alpha. Let's take one example. The speed limit of freeway in United States is 120 kilometers per hour, and assume standard deviation 2 because vehicle cannot maintain constant speed. Traffic police will measure the speed of the passing vehicle by using some device. Suppose traffic police conduct 3 measurements of the speed of the vehicle, recording as a random samples x1, x2, x3. The traffic police will or will not find the driver depending on the average speed of these 3 measurements. So here statistic is sample mean x bar. It is the average of these 3 values x1, x2, x3. Assume that vehicle speeds follow normal distribution with this mean 120 and standard deviation 2. Then this sample statistic will also follow the normal distribution with mean 120 and standard deviation of sample or standard error. It is sigma by square root n. Here it is 2 by 3 sigma by square root n. In this example, null hypothesis h0 will be mu equal to 120 kilometers per hour, and alternate hypothesis h1 is mu greater than 120. To reject this null hypothesis, if we perform hypothesis test at alpha level 0.05, then critical value should be calculated. That is the maximum error possible for this sample of size 3. Let's calculate the critical value C for this alpha level. Set greater than or equal to C minus 120 by standard error 2 by square root 3. For this alpha level, Z score is 1.645 for one tail test. So C minus 120 by standard error 2 by square root 3 will be equal to 1.645. If you solve that, C will be approximately equal to 121.9. Here is the critical region 121.9. If the recorded speed of vehicle is greater than this critical value 121.9, driver will be fined. There are 5% chances of driver falsely fined since the recorded average speed is greater than 121.9, but true speed does not pass 120, which is the type 1 error alpha. means suppose these three measurements taken were in the range of 2 kilometer span. The vehicle is actually moving with the average of 120 kilometers per hour. Vehicle cannot maintain the 120 same constant speed across this 2 kilometer span. So it will be faster in some place and it will be slow in some place, but overall speed is 120. But these three measurements were taken place where vehicle is actually moving fast. So its average found out to be something more than 121.9. But if you consider this entire speed means population, then its average would not exceed 120. Because of this sampling error, that mean was found to be more than this 121.9. This type of maximum error can be 5%, means falsely 5% of drivers can be at max fined. That is the significance level alpha. If the traffic police do not want to falsely fine innocent drivers, the alpha can be set to be smaller value, means this margin will be increased. So this critical value comes to here. Even if that sample mean false in this region, they will not be fined. Type 2 error is the conditional probability of failing to reject null hypothesis when it is actually false. It is denoted with beta, means for example true speed of a vehicle is on an average 125 kilometers per hour, but the three measurements were taken at some place where vehicle is actually moving slow and in other places it is actually moving fast. Average speed of that vehicle is 125, but that measured three values average is below this 121.9 critical value. Then that driver is not fined because this average speed falling within the 95% confidence interval of this null hypothesis. Actually null hypothesis is false. Actual true mean of that vehicle is 125, but this observed mean within this confidence interval of null hypothesis. So here the traffic police falsely do not find the driver, means null hypothesis is not rejected falsely. This kind of error is called type 2 error. In all these examples, we always testing this null hypothesis, not the alternate hypothesis. What is the reason for that? Actually, null hypothesis is based on the evidence from the past records, or which is generally assumed to be true. We know the distribution of our test variable under the null hypothesis. In our example, mean is 120 and standard deviation true. So our test statistic x bar will assume that this distribution is true. So this x bar will be compared against with this value, estimated value 120. But we don't know the distribution of the alternate hypothesis. That is the reason we will use null hypothesis always to test in the hypothesis testing.